This video is going to help with some of the problems on 9.3 homework. So number 1 says that Selena buys 4 peaches that weigh 1 pound total. So 4 weighs 1 pound total. Each peach weighs the same amount. Peaches are on sale for $2.42 per pound. So she bought 1 pound. So she paid $2.24. So first we want to write an equation, and then we're going to solve it. So we have an equation and we have a solution to find the cost of 1 peach. So lots of times when I am finding the unit rate, I know I need to divide, but I can never remember. Should I do 4 divided by 224 or 224 divided by 4? So I like to set up those proportions. So I know that I have my pounds, and I know that I have my money here, or this is right, peaches per pound. So I know when I buy this video is going to help us with 9.3 homework. So if you have any questions, be sure to follow along with this video. So number 1 tells us that Selena buys 4 peaches that weigh 1 pound total. Each peach weighs the same amount. Peaches are on sale for $2.24. So I know per pound. So I noticed she bought 1 pound. So I know she paid only $2.24. So we want to write and solve an equation to find the cost of 1 peach. So I know she paid $2.24, but that was for 4 peaches. I want to know how much she paid for each peach. So when I'm finding a unit rate, I know that I need to divide, but lots of times I get confused. Should I do 4 divided by 224? Should I do 224 divided by 4? And I just sometimes have a hard time deciding what I should do. So I like to set up that proportion. So I know I am doing peaches and money. So here's my peaches, here's my money. So I know that I bought 4 peaches and the money was $2.24. So every time I buy 4 peaches, it costs $2.24. But I want to know 1 peach. 1 peach, so 4 peaches, I'm putting it into 1 peach, and I'm looking for the money that cost me. So now I can use this to find my problem. So I know I'm doing 224 times 1, which is just $2.24. And I'm going to divide that by 4 here. So dividing by 4, and that's going to tell me the money for 1 peach, or the cost of 1 peach here. So if I was trying to get M all by itself, we've got to move everything to the opposite side. So we've been practicing these equations here. So I'd move everything to the opposite side. We've moved M to the other side. Then we would have to move this. And when we're dividing, the opposite is times. Then this, we'd have to move. It was multiplied. Now we have to divide. So that's how we came up with this equation here. So we know we do the opposite. So we're going to times, then divide here. So now I can solve this. So another way I could write this same equation is when I have 4 M's for each peach, then it is $2.24. So 4 amounts of the same money is $2.24. So to solve this, we can either do 224 divided by 4, or we can do the opposite here, times by 4, so we can divide by 4, divide by 4. So either way, we need to do $2.24 divided by 4. So once you have that, then we're going to graph that. So remember, this is like 10 cents, 20 cents, 30 cents. And I'm noticing that here there's not 10 marks to get to 10. So it's cut into 5 pieces, 10 divided by 5. So this is 2 cents, 4 cents, 6 cents, 8 cents, 10 cents. So if I was graphing 2 cents, I would just graph right on that. If I was graphing 5 cents though, here's 2, 4, 6. I know 5 is halfway between 4 and 6. So think about that as you are graphing that. Hey, number 2 tells us that a 120 volt battery is connected to a circuit with 30 ohms of resistance. The current in the amperes C flowing through the circuit can be found using the following equation. So I think lots of times when we read these story problems, like I just was like, okay, well, I don't know what that is. I don't know what that is. Like this is all like a foreign language to me. So let's just got to break it down. What do we know? So it wants us to use this equation. So it already set the equation up for us. We just need to find the variable, and we can do that. So pull out your equation and solve here. So this is 30 times C. So we want to divide by 30 on both sides. So this cancels out. So I'll let you go ahead and do 120 divided by 30 to find the solution to C. Okay, I'm going to skip to number 5. So just remember on all of these, you want to do the opposite on both sides. So Mr. Falco baked blueberry muffins several times in May using the recipe shown. He used 3 3/4 cups of milk in all. So this was his total cups of milk. And I can see over here for one recipe, it only needs 1/4 cup of milk. How many times did he bake muffins? So we're going to see how many groups of 1/4 go. So every time he used 1/4, we're going to times that by how many times he made muffins. And our total will end up being 3 3/4. So we're going to use this equation. So here we have 1/4 T. So we have 1/4 times T. So we want to do the opposite here, and that is to divide by 1/4. So remember when we divide, so here I'm dividing 1/4 by 1/4. But we need to do the opposite, the reciprocal here. We want to do copy, dot, flop. So when we divide, we want to take it and multiply by the opposite. 4 times 1 is 4, and 4 times 1 is 4. So this cancels out to 1. So here we have 1t. Now I need to do the same thing, divide by 1/4 to the other side. So my new problem is that I have 3 3/4, and we are going to divide by 1/4. So we need to make this first one improper, so we know how many pieces we have. So 4 times 3 is 12, plus 3 more is 15 over 4. So here's my copy. This is the same. Then I want to do the opposite of divide, dot, and the opposite of my division problem, flop, 4 over 1. So I notice that 4 and 4 have a common factor of 4. So I can really cancel these out, and I can finish and multiply my numerators and my denominators and see how many times he made muffins. So remember, when we multiply by this fraction, we have to do the inverse. We have to divide, which makes a division problem over here, copy, dot, flop, to get our division problem. Hey, number 6 says one ride on a city bus cost $1.50. I almost said 150. That'd be a very expensive bus ride. So it cost $1.50. Martina has $18 on her pass. So she's got this pass and it has a total of 18. And every time she rides the bus, it takes off $1.50. She rides the bus again, it takes off $1.50. So first we need to write an equation and then solve it. So this has two parts to it. How many rides can she take without loading more money on her bus pass? So how many complete rides without putting more? So even if there's $1 left, that doesn't allow her to ride on the bus again without putting more money on there. So first we want to write this equation. So we know it takes $1.50, and I can put that zero there or leave it out. It's the same. So that zero at the end is still 0 hundredths, 0 pennies. And every time she rides on the bus, it costs $1.50. So we're going to multiply that by how many times she can ride the bus, and we want a total of 18. So here's our equation. Another way we could write that is to say we have 18. We want to divide it by $1.50, and that equals the times she can ride on her bus. So here we have 1.5 times t. The opposite of multiply is to divide. So 1.5 divided by 1.5 is just 1t, which is what we want all by itself. So now we need to take 18 and divide it by 1.5. If you remember, when we are dividing with decimals, we can't have a decimal in our divisor. So we need to move this over so it's at the end. That means we have to do the same thing. We've got to keep everything balanced. So now our new problem is that we have 180 divided by 15. And we want to know how many times she can go. So our quotient here, our whole number, is how many times she can ride on the bus. If we have anything left over, that isn't going to help her get on the bus again. She'll have to add more money. So we just want this whole number here. So even if there's something left over, she'll have to save that for another time. Okay, I'm going to skip to number 14. So Mr. Nakamoto's gas tank is empty in his car. He refills the 11.6 gallon in his car with gasoline that costs $2.56 per gallon. So every time he did 1 gallon, it cost so I think I said 68. I'm not sure. $2.58 per gallon. And he did that 11.6 times. Which point on the number line shows how much Mr. Nakamoto pays for the gasoline? So it's telling us to use this equation that X divided by $2.58. So this X is standing for his total that he paid. So he takes the total and he divides it by how much 1 gallon is. And that tells him that he put in 11.6 gallons. So we want to show how much he paid. So we need to solve for this total here. So here we have divided by $2.58. So we have 1 over 1.28, and we want to multiply by 1.28 over 1. Sorry, I am writing that very backwards. I don't know where that number came from. Let me try that again. You're probably just as confused as I am right now. So let's retry that. So we want to multiply, because we are dividing, we want to do the opposite. So we have $2.58. That looks better. And the opposite of divide is to times by $2.58. So here we get $2.58 divided by $2.58 is just 1. So all of this cancels out. But now we need to do the same thing to the other side. So we multiplied by $2.58. So we want to take $11 or 11.6, and we want to multiply by 2.58. I actually think I want to rewrite this problem and do $2.58 and multiply by 11.6, just because multiplying by ones a couple times is going to be simpler than doing it the other way. So it will give us the same answer because of that commutative property. So remember, when you multiply by this first one, you'll want a placeholder. And when we multiply by this second one, we want 2 placeholders to get it all the way over to the hundreds place. And then when you're done, you have 3 decimal places. So once you have that answer, then you can decide which point on the graph represents his total that he paid for gasoline. Hey, and number 16 says that a grocery store sells long grain rice for $2.49 per pound. Write an expression for the cost of Y pounds. So notice it says expression. So every time I buy a pound, it costs $2.49. So if I buy 1 pound, $2.49. If I buy 2 pounds, I need to multiply this by 2. If I buy 3 pounds, multiply this by 3. So whatever I'm doing, I'm taking $2.49. So there's my coefficient, and I'm multiplying it by Y. We don't need to keep on going with the equation because it asks for an expression. So this is just the part of the problem that will help us solve for the answer, but it's not asking for the answer. It's just, this is how, if I knew how many pounds of rice I wanted, I would use this expression to find my equation and the answer. Okay, and our last one asks us to drag the fractions into the correct order from least to greatest. So I notice I have 8s, 12s, 9s, 6s, and fourths here. So we need to make common denominators, or we need to do something, another strategy to compare these. So I'm going to start here. I noticed something about 3 and 6. What do you notice about 3, 6? Well, I know that 3 is half of 6. So I know that this is the same thing as a half or 50 cents. I always like to think of fractions and change them into decimals because decimals go in groups of 10 and just make a lot more sense in my mind. So I noticed something about this one that's pretty easy as well. This is 1/4. When I have a quarter, how much money do I have? 25 cents. I'm actually going to come and add this 0 here just to remind myself that this is really 50 cents, not just 5 cents. Half of $1 is 50 cents. So I can see that 3/6 is bigger than 1/4. So I notice that 4 and 12 can be simplified. So a factor of 4 and 12 is 4. 4 divided by 4 is 1. 12 divided by 4 is 3. So we have 1/3. So I can't simplify 4/9 anymore, and I can't simplify 3/8, but I want to turn them into decimals. If you remember, this fraction bar just means to divide. I take 1 and divide it by 3, and I should get a smaller number because I'm dividing by a bigger one. So I'm going to add on a couple decimal places here. So 3 can't go into 1, but it can go into 10 3 times, which is 9. 1 left over, so 0.33. A third is always going to be 0.33. So I can do this one here. I have 4, and I'm dividing by 9. So I can see that 9 goes into 4, can't, but it can go into 40. 9, 18, 27, 36, 45 is too big, so it goes in there 4 times, which is 36, and 4 left over. So this looks like it's going to keep on repeating, 0.44. So I'm going to let you try this last one. So we have 3, and we're dividing by 8. And then remember, we want to put them from least, smallest, to biggest. So smallest on top, biggest on the bottom. Hey, if you have any other questions on your homework, please let me know and we can set up a time to meet.